line of study is.
Okay.
Or what you're proposing. Maybe you want to say you're
Yeah.
proposing more multiverses or something.
And we're set whenever you're ready.
I'm Max Tegmark. I'm a physicist here at MIT, and I love studying our universe.
Great. Perfect. Okay. I'm not sure where we should begin. How about?
I'm just going to
Oh,
have you for the
sorry.
eyeline. Just, yep,
Yeah.
that's good right there.
Sorry.
No, yeah, that's great.
And
Thank
the
you.
audio's, are we good
Yeah.
on audio levels and everything? Yep. Okay. Can you tell me briefly what does the multiverse mean? What is the concept of a multiverse?
When we astrophysicists talk about our universe, we don't mean everything that exists. We mean this. We mean the spherical region of space from which light has had time to reach us so far. Because no matter how good telescopes we build, if there's a galaxy out here, light from it just hasn't reached us yet. We have no access to it. If space itself is much bigger than this, if there's more to reality than we have any access to, then we call these other regions parallel universes.
Can we pause for 1 second? Is it possible to turn off the air, the fan? Just
Unfortunately, I have no control over that.
No problem then. Sorry about that.
Can you explain what that is?
This is our universe, or more specifically, the spherical region of space from which light has had time to reach us so far during the 13.8 billion years since our Big Bang. We're in the middle, and if there's a galaxy somewhere out here, then we have no way, no matter how much money we spend on telescopes, to see it, because light from there just hasn't had time yet to complete its journey and reach us in the middle.
And how bad is that construction sound? Is there anything we can do about that?
It's going to end soon, in just 3 years.
In 3 years? We've got time. I don't think there's any rush.
I mean,
there's nothing else happening, right? Okay. So basically, what you're saying is there's just a whole lot out there that we can't see.
Given that our universe, the part that we have access to in principle, is a finite part of space, it begs the question of whether there is more, whether there could be more to reality that we cannot see. If that's true, then we would call those other parts of space parallel universes. Do they exist or not? We don't know for sure. But interestingly, the best theories of physics we have actually suggest that yes, reality is much bigger than our universe.
So what are the theories that suggest that reality is much bigger than our universe?
Does space go on forever? Euclid thousands of years ago thought that it did, and I thought so when I was a little kid. It's the simplest kind of space you can imagine. It's hard to imagine it not going on forever. I mean, what's going to be there at the edge? A sign saying, like, warning, space ends here, mind the gap, or what? Sounds weird. Even though there are interesting models that Einstein and others came up with where space might actually be finite, the best theory we have for what created our space, made it so big, the theory called inflation, generally predicts that space is much bigger than this, typically even infinite, meaning that there are lots of other universes, regions just as big as our universe in the same space that we have no access to. They might seem irrelevant to us because we can't see them, but to someone who lives there, that's their universe. They feel it's real and they have no access to us. It sounds kind of harmless, maybe, the idea of infinitely many galaxies far away, but it's actually a pretty crazy idea when you think it through, because no matter how unlikely it is that the particles in our neck of the woods started out in a way that ended up forming our galaxy, solar system, and us, and led to this conversation, the probability of it happening isn't zero, because it happened here. So if you roll the dice again, an infinite number of times in other parts of space, it'll happen again and again. And you can even calculate that if you go about the Googleplex meters away in space, you'll find an entire copy of our universe where Googleplex is one with a Google zeros after it, and a Google is one with 100 zeros. And it's a long distance away, but much less than infinity. So if space is infinite and uniformly full of stuff like inflation predicts, then not only will there be copies of me out there, but also a lot of people who look a lot like me, but who live out all sorts of variations of my life. It's a sort of disturbing thought that we're led to by the most popular theory we have right now for what caused our Big Bang.
How's that ball looking in the shot right now?
So I think that we should actually do another shot. Yeah. Okay.
We're done with it.
I want to break it down and go through these things kind of like bit by bit.
You only have a minute for level 1 though, right?
It's going to come back to haunt me, isn't it? Well, what I would like to ask first is, okay, so the whole concept of basically space, what your line of study is.
Okay.
Or what you're proposing. Maybe you want to say you're proposing
Yeah.
more multiverses or something.
And we're set whenever you're ready.
I'm Max Tegmark. I'm a physicist here at MIT, and I love studying our universe.
Great. Perfect. Okay. I'm not sure where we should begin. How about?
I'm just gonna
Oh,
have you for the
sorry.
highlight. Just
Yeah.
that's good right there.
Sorry.
No, yeah, that's great.
And the audio's, are we good
Yeah.
on audio levels and everything? Yeah. Okay. Can you tell me briefly what does multiverse mean? What is the concept of a multiverse?
When we astrophysicists talk about our universe, we don't mean everything that exists. We mean this. We mean the spherical region of space from which light has had time to reach us so far. Because no matter how good telescopes we build, if there's a galaxy out here, light from it just hasn't reached us yet. We have no access to it. If space itself is much bigger than this, if there's more to reality than we have any access to, then we call these other regions parallel universes.
Hey, can we pause for 1 second? Is it possible to turn off the air, the fan? Just
Unfortunately, I have no control over that.
No problem then. Sorry about that.
Can you explain what that is?
This is our universe, or more specifically, the spherical region of space from which light has had time to reach us so far during the 13.8 billion years since our Big Bang. We're in the middle, and if there's a galaxy somewhere out here, then we have no way, no matter how much money we spend on telescopes, to see it, because light from there just hasn't had time yet to complete its journey and reach us in the middle.
And how bad is that construction sound? Is there anything we can do about that?
It's going to end soon, in just 3 years.
In 3 years? We've got time. I don't think there's any rush.
I mean,
there's nothing else happening, right? Okay. So basically, what you're saying is there's just a whole lot out there that we can't see.
Given that our universe, the part that we have access to in principle, is a finite part of space, it begs the question of whether there's more, whether there could be more to reality that we cannot see. If that's true, then we would call those other parts of space parallel universes. Do they exist or not? We don't know for sure. But interestingly, the best theories of physics we have actually suggest that yes, reality is much bigger than our universe.
So what are the theories that suggest that reality is much bigger than our universe?
Does space go on forever? Euclid thousands of years ago thought that it did, and I thought so when I was a little kid. It's the simplest kind of space you can imagine. It's hard to imagine it not going on forever. I mean, what's going to be there at the edge? A sign saying, like, warning, space ends here, mind the gap, or what? It sounds weird. Even though there are interesting models that Einstein and others came up with where space might actually be finite, The best theory we have for what created our space, made it so big, the theory called inflation, generally predicts that space is much bigger than this, typically even infinite, meaning that there are lots of other universes, regions just as big as our universe in the same space that we have no access to. They might seem irrelevant to us because we can't see them, but to someone who lives there, that's their universe. They feel it's real and they have no access to us. It sounds kind of harmless, maybe, the idea of infinitely many galaxies far away, but it's actually a pretty crazy idea when you think it through, because no matter how unlikely it is that the particles in our neck of the woods started out in a way that ended up forming our galaxy, solar system, and us, and led to this conversation, the probability of it happening isn't zero, because it happened here. So if you roll the dice again, an infinite number of times in other parts of space, it'll happen again and again. And you can even calculate, if you go about the Googleplex meters away in space, you'll find an entire copy of our universe, where Googleplex is one with a Google zeros after it, and a Google is one with 100 zeros. And it's a long distance away, but much less than infinity. So if space is infinite and uniformly full of stuff like inflation predicts, then not only will there be copies of me out there, but also a lot of people who look a lot like me, but who live out all sorts of variations of my life. It's a sort of disturbing thought that we're led to by the most popular theory we have right now for what caused our Big Bang.
How's that ball looking in the shot right now?
So I think that we should actually do the shot. Yeah. Okay.
We're done with it.
I want to break it down and go through these things kind of like bit by bit.
You only have a minute for level 1, though, right?
It's going to come back to haunt me, isn't it? Well, what I would like to ask first is, okay, so the whole concept of basically space as it is, as we know, the universe as we know it, just expanding infinitely beyond the Hubble radius. So it just goes on and on. Why would that be considered a parallel universe? Wouldn't that just be our universe going on forever? So that wouldn't necessarily be a multiverse.
If you choose to define the word universe, just mean everything that exists, then by definition there cannot be parallel universes. But that's not how we usually define universe in physics. We don't know how much stuff actually exists. It's much more convenient to define our universe to be the stuff we know exists, the stuff that we can see in principle, the stuff that light has had time to reach us from so far during the 13.8 billion years since our Big Bang. If you define it like that, then you can ask reasonably, is space bigger than our universe? Does space go on forever, or at least much farther than this? And if it does, well, then there are all these other regions just as nice and big as our universe, full of galaxies and solar systems and planets and maybe even people. And it would be very arrogant of us to claim that they somehow don't exist just because we can't see them. Much like it would be arrogant for an ostrich sticking its head in the sand to say that, oh, if I can't see you, you don't exist.
Okay, great. So can you tell me, without giving me all the explanation, can you just tell me that, like, how many different, like you have this theory of the four-stage classification of a multiverse, right? So can you just tell me that you have that? Like, how have you organized your thoughts about the different types of multiverses that might exist?
To me, the most interesting question is not whether there is more that exists than what we can see in principle, but rather how much more, and in fact, how many different levels of parallel universes there are. I would put my money on 4 different kinds.
Okay, great. And then so the first one we've talked a little bit about, but now let's do the kind of soundbitey version. So can you tell me what is the definition of the level 1 version of the multiverse?
The level 1 multiverse let's just wait 3 years. If it makes you feel any better, it's annoying for us too when we teach.
I don't think there's anything
we can do either, so I'm just gonna...
3 3 years waiting isn't so much compared to 13.8 billion years.
That's true. Could be worse.
Yeah. The level 1 multiverse sounds like quite a mouthful and weird and speculative, but you could equivalently just say space. If space itself is just really, really big, maybe infinite, like we thought as kids, and if what we call our universe is just a finite spherical region of space from which light has reached us so far since our Big Bang, and then there's room for a lot of these universes in space. That's the level 1 multiverse.
When you say a lot of these different universes, or there's room for a lot of these universes in space, that's assuming that they're all separate universes rather than one contiguous universe that we just can't see the other parts of.
It's important to remember that in the level 1 multiverse, there's nothing magical causing a sharp boundary between our universe and other parts of space that we can't see, any more than if you're out walking on a really foggy day and have a visibility of only 100 meters. You're in the middle of this fog sphere, which limits what you can see. It's not like space ends at the edge. You just have no idea what's beyond. Somebody over here are going to have their own fog sphere. So the different parallel universes at level 1 really blend together, and any one person is going to feel that their own universe is the sphere centered around them. It feels kind of egocentric, but I mean, this is simply a statement of our own ignorance. The boundary of our knowledge is what's taken 13.8 billion years for light to reach us from.
Perfect. Good. Thank you. Okay, and then how about just first the brief answer, and then we'll go into digging into it in a bit more detail. But what is inflation?
Inflation is the most popular scientific explanation for what caused our Big Bang, what made our space so big, expanding, and so uniformly filled with all this beautiful matter that right now spangles our heavens, galaxies, stars, and planets, and so on. And it's a remarkably successful theory, which we've done a whole series of tests on. This. A lot of my researchers focused on this too, and so far it's passed all of these tests. Inflation predicts that we live in a space which is very big and uniform, yes. That it's expanding, yes. That there was a Big Bang in our past, yes, check that. It predicts more specifically also that if you do a really big triangle in space, the angles will add up to 180 degrees like we learned in school. We checked that and it works, even though Einstein and others pointed out that there are a lot of weird spaces that aren't like that. Inflation also predicts these funny patterns that we see here in these incredible baby pictures of our universe, the way it was when it was only 400,000 years old, 13.8 billion years ago. I and many others have analyzed in great detail these patterns, and they behave exactly like inflation predicts. And there was these patterns which formed the sort of cosmic DNA and acted as the blueprint for where later on galaxies and ultimately planets and stars formed. So it's a very, very successful theory, which is why, despite so many attempts by so many smart people to come up with better theories, inflation is the one that's still taken the most seriously. We don't know that inflation happened, but it's currently the most mainstream explanation for what caused our Big Bang.
So we can see back to 400,000 years of when our universe started? We can see back that?
We can see things that happened. We can take photos of things that happened 13.8 billion years ago, just 400,000 years after our Big Bang. These are what the pictures look like. We can photograph the inside of this plasma sphere in all directions, from the hot plasma left over from our Big Bang. It's just pretty remarkable that we little humans on our spinning ball in space here can actually do science with something which is so crazy far away and so crazy long ago, and that the predictions actually work.
Yeah, it's really amazing.
Inflation, the theory of inflation says that our universe grew like a baby. People were one cell and then two cells, 4, 8, 16, 32, and we kept doubling. Inflation says that our universe did exactly the same. There was a tiny speck of stuff, it just kept doubling, 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 which in a short period of time made it really, really huge. And also flying apart with great speeds. It sounds like just a cool story, but it's actually something that pops right out of Einstein's equations of general relativity with very few other assumptions, and makes all sorts of nerdy predictions we can test by looking at the details of this data. And it's worked incredibly well, which is why my colleague Alan Guth and Andre Linde tend to look so happy when I see them these days.
Great. And would you mind, just so we've got it on record, just saying what Einstein's theory of general relativity is?
Einstein's theory of general relativity is the best theory we have for how space and gravity work. And it turns out there's an instability in them, where if you have a certain kind of substance, which is very hard to dilute, that starts expanding, it's just going to keep doubling and doubling and doubling and doubling, much like I doubled as a child, from 1 cell to 2 cells to 4, 8, 16, 32. And before you know it, kaboom, you created this vast universe.
Great. Now let's move on to the level 2 well, we kind of already have, but into
No, I haven't.
Let's talk about level 2 multiverse, which is related to inflation. Can you describe for me what the level 2 multiverse is?
The level 2 multiverse could still just be called space, because all of this stuff fits into one single continuous space. Whereas you could in principle imagine going to other level 1 parallel universes by just traveling for a really long time. There are some parts of space that you could never get to, even if you travel at the speed of light forever, because space between here and there is still doing this inflation and stretching out faster than you can get through it. Those other regions form the other parts of the level 2 multiverse. And the level 2 multiverse is more fun and diverse than the level 1 multiverse. If you go to another level 1 parallel universe and you find a planet with a school on it, those students will still learn the same things in physics class, even if they learn different things in history class, of course, because the particles started out in different places and the history unfolded differently. But if you go somewhere else in the level 2 multiverse, those kids might actually learn different things also in physics class, because inflation is so violent that it might have actually created different apparent laws of physics over there from here.
So the level 2 multiverse, that's with pocket universes.
Mm-hmm.
Is that the correct way that you refer to?
Alan Guth likes to call level 2 parallel universes pocket universes. That's right.
Okay. And so can you explain how those pockets are formed?
If you have bread that's rising in the oven, it can form pockets of gas inside, where there's no longer any bread. In the same way, if you have this inflating substance rising and expanding, you can form pockets inside where this inflation substance has gone away. And that's actually where it turns out that you make galaxies and planets and ultimately people. We live in one of those. Each one of those pockets is a level 2 parallel universe, with a whole level 1 multiverse perhaps in it. And it can feel like an infinite space actually from inside, because no matter how long you spend traveling, you'll never get to another pocket, because then you would have to travel through this inflating bread dough or substance which you can never get through. Yet the whole thing fits neatly into one single space.
That's a very good analogy. Could we also do a version of that that's just a very short one about how a pocket universe could work?
Can I have you also just sit up just a little bit? Yep, that's great. Thank you so much.
How it would work?
So just that just focusing on like a level 2 pocket universe, that would be like a loaf of bread expanding. The universe would be one of those little pockets, or something where you're basically just condensing. So we don't have to go into all the definition, but just the short version of that.
We somehow have to include there, though, that the thing is infinite. The thing is infinite.
Yeah, sure.
I can say that if there are many levels of parallel universes, I think of them as Russian dolls. For example, inside the level 2 multiverse, you can have a bunch of level 1 multiverses, and inside of each one of them, you can have a bunch of universes. The whole level 2 can in turn be inside of a level 3, which can be inside of a level 4. So they can all coexist happily. Did you want me to say something else also?
That's great. There was something else I wanted to ask that I know was just something about the level 2 pocket thing.
I mean, people often talk a lot about also what's the evidence for it, and how can the laws of physics seem to be different in different ones, but that might not fit into.
Might not. Ask about, the laws of physics are from one bubble in the loaf of bread to another bubble in the loaf. The laws of physics be different.
Even though the fundamental laws of physics are the same everywhere, the laws of physics that people studying physics would discover might seem different. If I'm a fish, I might think of the water I swim in as just empty space because it's all I know. But if I'm a smart fish, I can figure out maybe that this water obeys these equations with 3 solutions: liquid water, ice, and steam. In the same way, it seems like what we used to think was empty space is also a substance kind of like water that maybe can freeze and evaporate and come in different states. And interestingly, inflation is so violent that when it keeps making space, it actually makes all different kinds of space there can be. Ice, liquid, whatever you want to call them, and infinite amounts of each. We find ourselves here in this one, and we call the properties of our space just laws of physics, even though they're really just properties of the kind of space we're in. Someone who lives elsewhere in the level 2 multiverse, they would find that they have a space of different properties and might mistakenly think that's the laws of physics.
And so the level 2 multiverse, does it pretty much just correspond to like what Linde and Gut are saying about inflation potentially leading to multiverse? Is it the same, or is there variation in your theory?
The level 2 multiverse is what you get if you marry inflation with some fundamental theory of physics, string theory, loop quantum gravity, or whatever, that has more than one solution. So far, pretty much whenever we have some complicated equations for something in physics, or let me say it differently. Usually when we have some complicated equations of physics, they have more than one solution. The equations of water have 3 solutions, for example: liquid water, ice, and steam. And inflation has this amazing property that it doesn't just make space with stuff in it, but it makes space with all possible solutions for what kind of stuff there could be. So you get this incredibly diverse reality where everything that could potentially exist actually exists. Inflation is this incredibly creative force that actually transforms potentiality into reality.
What do you mean when you say solutions?
I mean, if you write down the equations for water, what you can make out of a uniform collection of H2O molecules, there are 3 solutions to this equation. There's the one where the water is a liquid, there's the one where it's a solid, ice, and the one where it's a gas, steam. And similarly, it seems that space itself and all the properties we learn about it in high school physics are actually the solutions to some basic equations. Maybe the string theory equations, maybe the loop quantum gravity equations. We don't know yet what the true equations are. But as long as there's more than one solution, more than one way in which space can be, inflation has this really creative side to it where we'll actually make all of them in different places. So, philosophers have often wondered about the difference between that something could exist and that something does exist. Inflation kind of eliminates that difference because anything that can be made, pretty much, it does make.
And how do we know that?
That's a very good question. When you first hear about parallel universes, it sounds just like flaky science fiction that has nothing to do with science, because we're talking about things we can't see. So we must remember that parallel universes are not a theory. They're a prediction of certain scientific theories. And if we take seriously the theory of inflation, because it's predicted a bunch of stuff that we've checked, then we're forced to also take seriously everything it predicts, even if we can't see those things. Physics theories are not like coffee where you can just like opt out of the caffeine and get decaf. If you buy the theory, you've got to buy all the predictions. And if you don't like parallel universes, then you have to throw away the inflation theory that predicted it and come up with some better explanation for our Big Bang, which we've tried really hard to do without that much success right now.
That's interesting, because it seems like the concept, although I'm not well versed in it, but it seems like the concept of a multiverse isn't totally established in scientific science.
No.
It's still kind of maybe controversial.
Yeah.
But like at the same time, it seems like the prediction of inflation would inevitably leads to a multiverse, right? So
That's right. We certainly don't know that parallel universes exist. This is quite controversial. We don't know that inflation happened either, even though it's the most popular theory. The thing is, though, inflation generically predicts parallel universes. So we can't have inflation without the parallel universes. And if you want to get rid of the parallel universes, then you have to come up with some better explanation of our Big Bang than inflation. And so far, despite a lot of smart people trying very hard, they have not managed to convince the community that their theory is better than inflation. That's why a lot of people are forced, kicking and screaming, to consider seriously the possibility that we could have these parallel universes. And just taking a step back, I mean, it's proven very difficult, surprisingly hard, to come up with a theory of physics that predicts only what we see and predicts that there's nothing else. And maybe we shouldn't be so surprised about that, because we humans have again and again and again underestimated the size of our cosmos, thinking that everything we knew of was all that existed. A planet, and then a solar system, and then a galaxy, and then a universe. And maybe we're wrong again. Maybe there's more. In fact, I don't have a single colleague in science who thinks that space actually ends here at the edge of our universe. Where it starts getting more controversial is when you ask, well, how much more space is there? And I think it's kind of arrogant, actually, to instead start by assuming that things that we can't see can't exist, because that really it sounds a lot like an ostrich with its head in the sand saying, oh, I can't see you, so you don't exist.
And why do you think there, I mean, maybe you just answered the question, why do you think there is resistance in scientific circles about the idea of a multiverse?
There are good objections to multiverses and bad ones. The good ones are simply objections that say, look, we don't know for sure that inflation happened. Let's make more experiments and check. The bad ones are people just saying, well, I just don't like the idea of there being stuff that I can't see. But our job as scientists isn't to use our emotional prejudice to tell our cosmos how to behave. Our job is to look with a really open mind and try to see, how is our world really? Okay, sure.
Next time, yeah, we'll just sorry about that. It's just one more time would be great.
Mm-hmm.
Thank you.
It's important to criticize theories predicting parallel universes, like it's important to criticize any theory in science. But there's good criticism and then there's lame criticism. The good criticism is to say things like, well, I'm really not convinced that inflation happened. Let's make more experiments and test inflation better. A lame criticism is to say stuff like, well, I just don't like the idea that there's stuff out there that I can't see. As a scientist, my job is not to tell the universe how to be, to conform with my emotional preferences. My job is to look at our universe with an open mind and see how it really is, whether I like it or not.
And then, although the various aspects of inflation have been confirmed and whatnot, and that's seen as kind of offering some evidence. Aside from theory of inflation, are there other tests that could be done for the concept of the multiverse?
Yes. So for level 1, to get more evidence for or against the level 1 multiverse, we should test inflation better. To test the level 2 multiverse better, we also should try to figure out whether string theory is right or wrong, or whether some other theory in its place has more than one solution. That's key. A third thing we can try to do is to find out whether certain constants of physics that we measure, like the amount of dark energy, are actually fine-tuned. It seems like a lot of properties of nature have been dialed in with just the right values to allow life. And if you messed with them a little bit, terrible things would happen. And the level 2 multiverse beautifully explains why that would be so, by saying that actually the amount of dark energy, for instance, is different in different parts of space. And you can calculate that you can't make any galaxies unless the dark energy is set to this very special value. So if we live in a galaxy, that's where we're going to be. Duh. It's just like if I find myself living happily for many years in the Sahara Desert, I'm probably in an oasis. If I'm living in the solar system, I'm probably not on Pluto or an empty space. I'm somewhere where I can live. That's the only explanation we have right now for these apparent coincidences, other than saying, well, there was a creator who made our world and just dialed in these parameters. And so another interesting thing one can do is actually look more carefully, measure these things, and try to see if there is any other scientific explanation for all these coincidences. And if there isn't, then that's another victory for the idea that reality is bigger than we thought. That was very long-winded. Let me just say, yeah. Sometimes we can get evidence. Sometimes we can get evidence for the existence of things we can't see from funny coincidences that get explained that way. Suppose we didn't know anything about other solar systems or other planets, and we noticed that there's something weird because Earth's orbit around the sun is exactly right for there to be liquid water on our surface. If we were a little farther away, it would be like Mars and all ice, and closer would be like Venus. That would suck. So isn't that a weird coincidence? Of course it's not, because there are many planets and there are many other solar systems with planets in all kinds of orbits. Are we surprised that we live on one that's just right? No. But so we could actually have used that argument to predict, before we knew it, that there were probably other planets out there. And in the same way, we can actually use the fact that some constants of nature seem really fine-tuned to be able to have atoms and have life, to infer that there's probably other regions of space out there where those values are different, which is exactly what the level 2 multiverse says. In fact, Steven Weinberg, famous Nobel laureate, first predicted that there should be dark energy of exactly a certain range of values. And most people dismissed this because he used this kind of argument based on a multiverse. Until, lo and behold, it was found experimentally that we have dark energy. It exists, and it has about just exactly that value that he had talked about. And I think studying those things more can also add more evidence for or against the multiverse.
Great. And then in terms of the anthropic principle that you were discussing, would it be possible just to get kind of a quote about how basically, the level 2 multiverse means that there are many different, possible physical realities or something, or talk about how the fact that our reality is so primed for life isn't surprising because there are so many other physical realities that could be not primed for life, or that topic, but in a
Briefer.
Yeah, just in a little brief.
In science, we hate unexplained coincidences. If a theory requires a bunch of unexplained coincidences to match the data, we say that that theory is just ruled out. And we found a bunch of unexplained coincidences in nature. For example, the dark energy density that we measure, you have to tune it to 123 decimal places. Otherwise, there are no galaxies. Like, whoa, who ordered that? And amazingly, the level 1 multiverse explains that coincidence. So if you buy into it, it's a better theory by not requiring any sort of magic. It simply says that space is really big and diverse, and you have all kinds of different amounts of dark energy in different places. There, you can calculate that there will only be galaxies in the places where the dark energy is just right. So given that we're observing from a galaxy, we can predict that we're going to see this special value. And this is exactly the same sort of logic you would use to say it's not the coincidence that we are finding ourselves on a planet which is unusually fit for life. You know, I mean, we're not going to be living on Pluto. And exactly the same reason why we're not surprised that we're not living in a random part of space. We're living actually in a solar system, not in an intergalactic void. If you don't like the level 2 multiverse explanation, then you're really stuck with this feeling that somebody must have designed our universe and just sort of hand-tuned the value of the dark energy, which isn't really much of a scientific explanation unless you can explain, well, who designed it or what designed it and why.
In the first part of the answer, you said level 1 multiverse. Is that?
Did I? Or maybe I accidentally misspoke.
I think you may have.
Yeah. So did you redo that?
Do you mind just doing it one more time? Sorry, and then
No,
we'll
no,
move
no.
on.
So.
And if I could just have you lean the other.
Sorry, so left leaning. No problem. Okay, so let's see. Where were we here again?
Basically, just looking at how the level 2 multiverse kind of addresses.
Yeah, we talked about how we don't like unexplained coincidences in science. Yeah. I feel the key difference between a scientific explanation and an unscientific explanation is whether you're willing to live with unexplained coincidences. We have found that the dark energy density that we've measured has to be fine-tuned to 123 decimal places for there to be any galaxies. An unscientific explanation would be to say, well, just it's coincidence, deal with it. Or to say, well, you know, somebody or something created our universe and chose to dial in the value of this like this, but then not have any theory for what the creation was. There is a scientific explanation which doesn't require any coincidence, which is to say the level 2 multiverse exists. We just have this big space where we have different amounts of dark energy in different places, which comes out of the math. And there are only going to be galaxies in places where the dark energy has this very special range of values. And given that we're looking from a galaxy, that's what we're going to measure. There is no coincidence. No more than it's a coincidence that we find ourselves on one of the very few planets that supports life. And we're not going to be living on Venus.
Thank you. Good. And then, would you mind, before we go into level 3, just, you know, you mentioned earlier kind of how humanity's conception of where we are in the universe has changed over time, right? So, you know, you said we're the center of the universe and all that. Would you mind just talking about that for a little bit?
Sure. We humans, I feel that we humans need to learn to think big because we've repeatedly underestimated not only the size of our cosmos, thinking that, let me say it again, I feel that we humans need to learn to think big, because we've repeatedly underestimated not only the size of our cosmos, realizing that everything we thought existed was part of a much grander structure, a planet, a solar system, a galaxy, a universe, and maybe a hierarchy of parallel universes, but we've also underestimated the power of our human minds to understand the cosmos. And that, I think, is actually a very inspiring and empowering thought.
Thank you. Cool. So now we're going to dive into the one that I struggle with the most, level 3.
Okay. So level 4 is a piece of cake for you.
Oh, well, that's just beyond even comprehension, so I'm not worried about that one. But level 3 is the one that I can't, yeah. So, tell me about level 3.
Level 3 parallel universes are actually very much like level 1 parallel universes. If you were to live in one, the laws of physics seem the same as here. It's just that stuff happens differently. You know, here you get a parking ticket, there you don't. The difference is where they are. Level 1 parallel universes are really, really far away in our good old 3-dimensional space. Level 3 parallel universes are elsewhere in this abstract mathematical space called Hilbert space of quantum mechanics. And the reason you get led to this, yeah, I should probably stop there so you can cut. Whereas inflation tends to predict the level 1 multiverse, this equation, the Schrödinger equation of quantum mechanics, if you don't fudge it or tweak it in any way, predicts the level 3 multiverse. Because if this equation applies to everything, then little particles can be in multiple places at once, which we've tested in the lab. But I'm made of particles. So if they can be in several places at once, so can I. So our whole world actually can be in a state, for example, where I'm right now a physicist, and another state where I'm a gardener at once. And these will appear to their inhabitants as just two parallel worlds doing their own thing.
Okay, now at the quantum level, so particle can be in two places at once, but we're made up of like many, 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 many particles. So
Yeah,
it's
10 to the
possible
28.
That kind of like locks it in so that it's not that all of our particles can act simultaneously to suddenly appear in another universe.
Do you mind just putting that frame down, actually? Thanks.
I mean, is it possible that, that quantum kind of effect only applies at quantum levels and
Mm-hmm.
we were to...
When quantum mechanics was born about a century ago, a lot of people hoped that this quantum weirdness, where things could be in several places at once, could be confined to the micro world and we would never notice. But then Erwin Schrödinger, who came up with this Schrödinger equation, realized that that's not so. Even if you just have one little atom doing two things at once, you can, for example, couple that atom to a trigger of a terrible device which will kill a cat if the atom does one thing and let the cat live if it does another thing. And now the quantum weirdness in the micro world of the atom has been amplified to a weird cat that's alive and dead at once. In fact, every time I make a snap decision, which is caused by what just perhaps even one atom was doing in the beginning in my brain, and then that got amplified into me deciding to step on the gas and try to run the red light or hit the brake, can gradually cause the whole world to take two very different courses of action. One where maybe I get hit by a truck and the other one where I'm fine. So, no, the quantum weirdness cannot be confined to the micro world, yet we don't see it in the everyday world. That's why physicists still argue about this 100 years later.
I guess I don't understand how it works. So you make a decision and then in a parallel universe...
No, there's only one. Quantum mechanics says there's only one reality. It's just very big in this place called Hilbert space, where the wave function of this equation is. But within this big, full reality, what started out seeming to its inhabitants as just sort of one world can actually end up effectively splitting into two parallel storylines, the way it seems to them, where different things happen. So, for example, if I'm driving and the light turns yellow, and I'm trying to decide, should I hit the brake or the gas pedal? That snap decision might come down to maybe what just one little atom is doing somewhere in my brain, which triggers a cascade of neuron firing and makes me make the decision, and then maybe I get killed in the branch where I tried to run the light and was hit by a truck, and I survive in the other one. And before long, I now have these two very, very different stories playing out in this big quantum reality.
Where is the big quantum reality?
The big quantum reality is in a place called Hilbert space, which is where all the quantum action takes place, and it's a really big place. It's not three-dimensional like this space we're in, but perhaps infinite dimensional. But it's still only one reality, and we only have access here to this small part of it that corresponds to a roughly classical world where one story has happened. And the only way we actually become aware of this quantum weirdness is when our past apparently splits into two. Then each version of you will feel that only one thing happened kind of at random. So my guess is that actually this weird quantum splitting is the explanation of apparent randomness in the world. Other people don't like this and think that instead the quantum weirdness goes away because this whole equation is ultimately wrong, and this thing called the wave function collapse happens, and in Einstein's word, God plays dice, and something truly random happens to nature. Einstein didn't like this idea. Many other physicists don't either, but some do, and it's one of the most controversial subjects in science. What I love about the level 3 multiverse controversy is that it's actually not just about philosophy, but about something we can test. There are millions of dollars right now being spent on building quantum computers, which actually exploit quantum weirdness to be able to solve problems much faster than a normal computer can. If we can one day make them work, then there will, the way I like to think about it, be actually exploiting the quantum parallel universes as a resource for parallel computation, which would make it much harder to deny that those other worlds are there. Whereas if they don't work, and we really dig into details of why, and we find out that the reason they don't work is because there's some extra math added onto this equation, right? Then there are no level 3 parallel universes. This is how to test it.
Do you think there are? Do you personally, do you think there are level 3 parallel universes?
My guess is that there are, yeah. I think my job as a scientist isn't to believe. My job as a scientist is to look at the evidence and see what it sort of suggests. But I like betting. I'd bet my money on that there is actually 4 different kinds of parallel universes, and that the ultimate physical reality is simply bigger than what we humans have any access to.
I read some kind of, some of the controversy about the level 3 approach. Someone saying that it's more of the realm of philosophy than science.
It's really interesting how the parallel universe debate has changed in my lifetime. It used to be largely dismissed as just philosophy. Then inflation came along and made people take the level 1 multiverse more seriously. Then dark energy was discovered and made people take the level 2 multiverse more seriously. And then all this wonderful quantum technology came along and made people take the level 3 multiverse more seriously, because that's what makes the difference about whether these things we're trying to build will actually work or not.
Okay, great. So we're ready for number 4?
So there's not just ideas on the line, but money on the line.
Sorry, will you say that again?
No, you can just cut that into the end of my last thing.
I think I may have been speaking when you said that. I'm not sure. Would you mind taking that line again?
So there aren't just ideas on the line, there's money on the line.
Okay, great. Thank you.
The Economist.
Exactly. Are we ready for number 4?
Bring it on.
It's you that has to bring it. So tell me, what is the level 4 multiverse?
If 3 levels of multiverse aren't enough for you, welcome to the level 4 multiverse. A lot of my students here at MIT like to wear these really geeky t-shirts with equations written on them, and the dream ultimately would be to come to school with the equations for the theory of everything. Maybe string theory, maybe something else that can describe everything about our reality. But that would still leave you wondering, like, well, why those equations, not some others? So the level 4 multiverse is the idea that every mathematical structure, it's described with some equations, corresponds to an actual existing universe. One of them will be the one we're in. Other ones are vastly simpler, like this mathematical structure, the dodecahedron, with its 12 pentagonal faces. Other ones are very complicated and different in all sorts of other ways. So the level 4 multiverse is the most diverse of them all, if it exists. And
But something there. Do you need to tell people to be quiet in the hallway? How are you doing with that?
I think we're okay. It's mostly the yeah. Maybe we'll just move that inflated universe. Bye, universe.
the
Thank you. Okay. Actually, yeah. We have to say.
Okay.
yeah, going to intimidate them. How are we doing so far?
We're doing very well. Thank you. I think it's really interesting.
It's fun to talk about
Yeah.
these.
I do struggle with level 3 though, I know.
Is everybody? Oh, that's the fun of it.
I don't know what to do.
Does this interview go behind a paywall?
No.
Oh.
Wait. In some places it will be, but no, it'll be in front in the multimedia library.
Oh,
Sorry.
awesome!
Yeah.
Which I can share it with my mom and stuff.
Yeah. Oh, that's sweet.
Let me know whenever we're ready.
Yes. Sorry about that.
You can give me the whole librarian thing. That's always fun.
I did get to use the library.
Let me know when I can.
Yeah, just 1 second.
What leads to the level 4 multiverse is the idea that our physical world is completely mathematical, meaning that it has no properties at all except mathematical properties. And that sounds really nutty when you first hear it, because I mean, look around here and this doesn't look very mathematical. I mean, what properties does this juggling ball have here? It's squishy, purple and pink and blah. What's mathematical about that? Yet, I know as a physicist that this is made out of quarks and electrons. And what property does an electron have? It has the property -1, 1/2, 1. We physicists have geeky names for these properties like electric charge, spin, and lepton number, but the electron doesn't care. Those are just numbers, right? And as far as we can tell, all the particles that make up everything here in the world have no properties except numbers like that. What about the space that all these particles are in? What properties does empty space have? Well, empty space has the property 3, because that's the largest number of pencils I can hold that are all perpendicular to one another. 3. Again, we have a nerdy name for it. We call it the dimensionality of space, but space doesn't care what you call it. The property is just 3. And as far as we can tell, neither space nor any of the stuff in space actually has any properties at all other than mathematical properties, which makes it sound a little bit less ridiculous, the idea that maybe we're all in this mathematical structure, something like this mathematical structure, but something more beautiful and complicated.
Okay, great. And now can you give me the TV version of just that what the 4th stage of the multiverse is described by mathematics, or something that's just a few sentences? What's the shortest version you can give me of that for the top level before we go into describing it further?
Don't know if I can do anything shorter. But there are 2 separate logical pieces here. First of all, the idea that the world is completely mathematical. That's why my book is called Our Mathematical Universe. And then there's a separate argument about that it's not just that we live in one mathematical structure, but there are all these different ones, which are all physically real worlds.
That's
right?
exactly it.
Yeah.
Can you give me that?
But I was just saying, I wasn't justifying anything.
No, that's what I mean. Like, that's like the intro topic, and then
Mm.
we can go into the justifying
Okay.
everything.
Am I allowed to mention the book? Or?
Let's not, if you don't.
Mm-hmm. The level 4 multiverse rests on two ideas. The first one is that our physical reality is completely microphone free.
Yeah.
Yeah.
Here, let me take
yeah,
you back.
that'd be great.
Oops, wait, I keep doing that too. Is that okay?
Yeah.
Or did I
Just be
make it-
careful with arm
I'll
movements.
just-
I know, I'm sorry.
I know I'm
have so
hopeless.
many
I'm
rules.
so.
Sorry.
Sorry, just pin you in here in this little box.
Yeah.
If you answer questions.
Can I ask a quick question of you?
Yeah.
Looks like we only have 4 minutes left
Oh,
on the
okay.
B card. Does that then switch over to the A?
We should wipe the A card before we
Would
do
you
that.
like-
So let's
Makes-
let's
just don't
finish
wipe
this
Alan
one.
Goose
Okay,
by
this is
mistake.
the fourth
Sure.
one, and then we'll.
The level 4 multiverse rests on two ideas. First, that our physical reality is purely mathematical, having only mathematical properties. And the second, now let me say it differently. The level 4 multiverse rests on two different ideas. First, that our physical reality is a mathematical structure. And second, that each of the many different mathematical structures that mathematicians discover corresponds to its own physically existing reality. That